High above the horizon, beyond the naked eye, a new silhouette began to carve its presence into the skies. It was not just another fighter jet, it was a symbol. Born from a desire to break into the highest echelon of aerial warfare, the Chengdu J-20 emerged as a manifestation of technological ambition, geopolitical necessity, and the relentless pursuit of aerial supremacy. The skies have long been dominated by aircraft-bearing designs from traditional aerospace giants. Yet, among them, a new contender arose, not from a country typically associated with cutting-edge fighter development, but one that was rapidly ascending in both technological and strategic capability. The Chengdu J-20, often nicknamed the Mighty Dragon, became that symbol. The story of the J-20 begins with a vision. A vision to create a fifth-generation stealth fighter with advanced capabilities, one that could rival any counterpart flying in the skies of the West. This was not a project born overnight. Decades of research, lessons from imported designs, and an expanding domestic aerospace industry converged to make the dream a reality. Sleek and menacing, the J-20's design reflects a careful balance between stealth, speed, and agility. Its forward canards and angular fuselage are tailored not only for visual intimidation but to reduce radar cross-section, a hallmark of true stealth technology. Engineers studied global trends in stealth design and crafted something distinctly national, combining global knowledge with indigenous innovation. This aircraft is not just about appearance. Within its frame lies a sophisticated suite of avionics, sensors, and radar systems. Pilots benefit from a cockpit filled with advanced displays, sensor fusion, and communication tools that give them real-time awareness of the battlespace. These tools are essential for the kind of roles envisioned for the J-20, long-range interception, deep strike capability, and even limited dogfighting if the mission calls for it. Powering such a machine requires engines that match the ambition of the airframe. While early iterations relied on foreign components, national efforts soon focused on creating an engine that would not only fit but elevate the aircraft's performance. This engine, crafted under intense development and secrecy, represents the effort to secure full autonomy in military aviation. The J-20's capabilities do not stop at stealth. It was designed with a long reach in mind. With internal bays capable of housing a variety of weapons, ranging from beyond visual range missiles to potential future air-to-ground munitions, the aircraft can strike from distances that make retaliation difficult. These internal bays also ensure that its stealth profile remains intact, avoiding the Dragon radar signature associated with external weapon pods. But weapons are only one part of the equation. For modern fighters, information is as important as firepower. The J-20 is designed to act as a sensor node, capable of absorbing, interpreting, and sharing data across a network. In a conflict environment, this aircraft could function as a command and control platform, relaying data to other units and increasing situational awareness across an entire formation. More than just a tool of war, the J-20 represents a shift in global dynamics. For the nation that built it, the aircraft is a statement of intent. It is a declaration that the era of technological reliance is fading, and that indigenous innovation is stepping forward with confidence. For other nations, it is a sign that air superiority is no longer guaranteed. As the J-20 took to the skies in its early test flights, the world watched closely. While secrecy surrounded its development, enough glimpses emerged to stir conversation across global defense circles. Observers began to speculate about its true capabilities. Was this simply an advanced prototype, or had a new standard of aerial warfare been born? From those first takeoffs, it became clear that this was no hollow showpiece. The aircraft demonstrated impressive agility for a stealth platform of its size. With sharp angles, smoothly blended surfaces, and a design focused on evading detection, it held its own among the elite. But beyond the visual analysis, deeper insights came from how the aircraft was deployed and tested. Test pilots played a critical role in refining the jet's performance envelope. Maneuverability was put to the test in various conditions: low-level flight, high-altitude interception profiles, and simulated combat scenarios. Feedback from these missions shaped adjustments in flight control systems, weapon integration, and radar calibration. Not content with just producing a stealth fighter, the development teams also focused on sustainability and flexibility. Maintenance procedures were streamlined to allow for faster turnaround times. Ground crews received specialized training to handle the aircraft's unique surface materials and sensitive electronics. Logistics chains were reorganized to support deployments to distant airbases, ensuring that the J-20 could respond swiftly to changing threats. One of the most defining aspects of the J-20 is its role in the broader aerial strategy of its homeland. Unlike traditional fighters that focus purely on dogfighting or ground attack, this platform is part of a network-centric doctrine. Its sensors are designed to operate in tandem with satellites, ground stations, and unmanned platforms. This synergy allows it to punch above its weight, leveraging external data to enhance targeting and survivability. Strategists see the J-20 not just as an aircraft, but as a node in an ecosystem. When deployed alongside drones, early warning planes, and support craft, it becomes a force multiplier. In scenarios where electronic warfare or cyber interference is likely, the J-20's avionics are hardened, allowing it to continue operating even under contested electromagnetic conditions. The design choices reflect a blend of caution and ambition. While prioritizing stealth, the inclusion of forward canards sparked debate. Some experts questioned whether this choice might compromise radar evasion, but developers insisted that modern software and materials had reduced such trade-offs. Moreover, the canards contributed to stability and maneuvering, especially during complex aerial engagements. The cockpit itself reveals another layer of sophistication. Pilots operate within a bubble of information. Multifunction displays offer clear, customizable data feeds. Artificial intelligence helps manage sensor inputs, prioritizing threats and reducing workload. This allows the pilot to remain focused on mission objectives rather than being overwhelmed by raw data. Training for J-20 pilots is equally rigorous. Candidates are drawn from elite units, selected for their adaptability and cognitive skills. In simulators, they face scenarios that test decision-making under pressure. Real flight hours are spent mastering complex maneuvers, formation flying, and high-speed targeting. These efforts ensure that the aircraft's potential is matched by the skill of those who fly it. Outside observers note the increasing frequency of J-20 patrols and joint exercises. The aircraft is no longer confined to test bases, it now plays an active role in regional air operations. Its presence near strategic airspaces is both a show of strength and a statement of deterrence. With every deployment, the aircraft sends a message: the nation that built it is ready to defend its skies and challenge traditional power structures. Beneath the sleek exterior of the J-20 lies a dynamic battle between ambition and realism. Achieving true stealth in an aircraft is not merely a function of shape, it requires innovation in materials, electronic systems, and exhaust management. The J-20 incorporates radar-absorbing coatings, edge alignment, and carefully contoured surfaces, all tuned to scatter and absorb signals from hostile detection systems. Efforts to develop a homegrown engine capable of sustaining the jet's high-performance requirements became a national priority. Producing engines that deliver high thrust while remaining stealth-compatible is among the most technically demanding tasks in aerospace engineering. While earlier versions relied on imported powerplants, engineers pressed forward with domestic alternatives. These engines were designed not only for speed and acceleration but also to reduce infrared signature, an essential factor in avoiding heat-seeking missiles. Fuel efficiency, range, and climb rate are all shaped by engine performance. With the right propulsion system, the J-20 gains extended reach, allowing it to project power farther from home bases. This is crucial for roles involving maritime patrol, long-range strike, and airspace interdiction. The farther it can fly without needing refueling, the more strategic value it brings to the table. Weaponry onboard the J-20 is stored within concealed bays, a decision made to preserve its stealth profile. These internal compartments carry medium to long-range missiles designed for air dominance. Unlike previous generation jets that relied on a mix of visible pylons and payloads, the J-20 keeps its arsenal hidden until the moment of engagement. This reduces radar detection and enhances survivability. One of the most debated topics surrounding the J-20 is its true intended role. Some analysts argue that it is designed primarily for air-to-air combat, aimed at neutralizing threats before they get too close. Others believe it has a broader mission scope, capable of deep strike missions, surveillance, or even electronic warfare support. Its adaptability is one of its greatest strengths. It can be reconfigured depending on the mission, whether that means serving as a hunter, scout, or spearhead. A defining feature of the J-20's strategy is its ability to operate in contested environments. Modern air combat is not simply about maneuvering and missile range, it is about surviving in an arena filled with jamming, hacking, and data disruption. The aircraft is equipped with countermeasures to protect its systems from external interference. It can also jam enemy radars or communications, making it a ghost in the skies. Its avionics allow for secure communication between allied aircraft and ground control. In modern conflicts, information superiority is often the deciding factor. The J-20 can relay sensor data to ground units or fellow pilots, creating a shared view of the battlefield. This networked approach means that each J-20 enhances not just its own performance but also that of the larger force. Moreover, stealth does not mean invisibility. Opponents can still detect a stealth aircraft under certain conditions, especially if they use advanced multi-spectrum sensors. The J-20's designers accounted for this by incorporating agility and electronic warfare systems that enable it to avoid or confuse such threats. Should it be targeted, the jet can deploy decoys, change radar signatures, or break lock-ons through evasive maneuvers. The international community took note of the J-20's rising capabilities. Observers compared it to other stealth platforms and debated its place in the hierarchy of fifth-generation jets. Some were skeptical of its engine performance, others questioned the depth of its stealth, but as flight hours increased and operational deployments became more frequent, the doubts began to fade. The aircraft proved resilient, adaptive, and worthy of its growing reputation. Beyond the hard specifications, the J-20 represents a philosophy shift. No longer is aerial dominance dictated by a handful of powers. A new contender has emerged, one that not only builds stealth fighters but integrates them into a broader, forward-looking military doctrine. The future of air combat, once narrowly defined, is now being redrawn with fresh lines. The journey to operational readiness for the J-20 was shaped not just by engineering triumphs, but also by shifts in doctrine and training. Building an aircraft of such complexity demands a support structure just as advanced. Training squadrons, testing facilities, and technical colleges were overhauled to prepare the next generation of pilots and technicians for this new breed of fighter. Pilots selected to fly the J-20 come from the top ranks of existing air units. Their profiles are not limited to physical skill, they are chosen for problem-solving ability, digital literacy, and adaptability. With every flight, they become part of an evolving testbed for new strategies and technologies. The J-20 changes how aerial combat is taught, moving away from brute force dogfights to data-driven engagements. On the ground, engineers constantly monitor performance metrics, feeding data into simulators and redesign cycles. Maintenance routines are guided by predictive algorithms, reducing downtime and increasing mission availability. The aircraft was not built to sit in hangars, it was meant to be airborne, ready at a moment's notice. These new logistics models allow for rapid deployment, even to remote airfields or temporary locations. From a political standpoint, the J-20 has become a symbol beyond its capabilities. It reflects the priorities of a rising power that seeks to redefine its role on the world stage. This jet is often showcased at airshows, not only to inspire national pride but to signal technological parity with long-established aerospace giants. Its appearance in diplomatic exchanges and defense negotiations underscores its strategic value. The psychological impact of stealth is profound. Knowing that an adversary possesses aircraft capable of penetrating defenses without warning changes how nations plan their air strategies. It forces others to invest in counter-stealth technology, spreading resources thin across new detection systems, interceptor development, and satellite-based tracking. Yet, despite its stealth, the J-20 is not invincible. Designers have continued to iterate, pushing new variants into production and testing. Rumors suggest upgraded engines, improved radar arrays, and even enhanced stealth coatings are being implemented. Each new version brings it closer to complete independence from foreign components, a key goal for the program. These developments reflect a larger trend toward homegrown innovation. The aerospace industry behind the J-20 has become a hub of scientific research. Universities and defense labs collaborate to test new materials, propulsion concepts, and autonomous systems. The aircraft has become not just a product, but a platform for experimentation, fueling breakthroughs that could shape future airframes and aerial drones. Beyond national defense, the J-20 program has also spurred civilian applications. Innovations in lightweight composites, high-speed computing, and aerodynamics are being adapted for commercial aviation. The lessons learned from building stealth jets filter into cargo transport, air traffic management, and emergency response technologies. In regions where the J-20 operates, its presence changes the balance of power. Neighboring air forces must recalibrate their responses. Airspace monitoring becomes more aggressive. Patrols are extended. Alliances are reinforced. Every sortie by the J-20 is watched, recorded, and analyzed. In this sense, it is not just an aircraft, it is a piece of diplomacy in motion. Some critics argue that the true value of stealth lies not in battle, but in perception. The mere belief that a stealth jet may be present in the area causes adversaries to hesitate. That hesitation can delay decisions, alter battle plans, or divert resources. The J-20 plays this role masterfully. It influences conflict zones even when it remains unseen. Its silhouette has become iconic. Sharp lines, twin-engine nacelles, forward canards poised like the wings of a bird of prey. It is a reminder of the merging of design elegance and functional power. Whether soaring through drills or slicing through cloud cover on a high-stakes patrol, it carries with it the weight of national ambition and the hope of technological leadership. As the J-20 matures, it is no longer just a project, it is a central pillar of a broader vision for air power. A single platform rarely defines an entire air force, but this aircraft has become an exception. It influences everything around it, from training methods to strategic doctrines, from research priorities to regional diplomacy. A key element of this transformation is adaptability. While the airframe was originally designed with stealth in mind, developers foresaw a need to make the J-20 flexible. They built it to grow. Modular design elements, upgradable sensors, and scalable software make it future-proof. As threats evolve and new technologies emerge, the jet can evolve with them. This adaptability is already visible in mission planning. What began as a stealth air superiority fighter now performs a range of roles: deep strike, command relay, reconnaissance, and electronic disruption. Its advanced communication suite allows it to act as a flying command post. In exercises, it has linked together strike packages, coordinated drone formations, and provided targeting data to ground batteries. Such versatility demands high levels of coordination, which is where artificial intelligence and automation come into play. The J-20 leverages machine assistance to manage the flow of data. Enemy radar signals, friendly positions, terrain maps, and sensor inputs are filtered and prioritized. Pilots receive only what they need, when they need it. This human-machine partnership reduces decision lag and increases survivability. Meanwhile, strategic deployments of the J-20 are carried out with deliberate timing. It is not a platform that simply appears on a runway. Each sortie is calculated, whether patrolling contested air corridors, shadowing surveillance planes, or flying alongside naval task groups, its presence signals resolve. These missions are tracked closely by foreign analysts, who attempt to decode not just what the jet does, but what it implies. The J-20 also plays a subtle role in psychological warfare. The sighting of its sharp silhouette or the rumor of its deployment is enough to trigger responses. Fighter jets are scrambled, defense systems are activated, protocols shift. Even without firing a shot, the J-20 reshapes the battle environment. In this way, it becomes a weapon not only of combat, but of influence. Yet beneath the polished canopy and stealthy angles lies a very human endeavor. The jet represents years of sweat, revision, failure, and triumph. Aerospace engineers worked around the clock, often revising entire subsystems based on test results. Pilots endured rigorous training and countless simulations to master its flight behavior. Support staff, logistics teams, and software developers all played their part. It is also a story of ambition versus constraints. Developing a fifth-generation fighter is not simply a matter of will. It requires overcoming gaps in experience, supply chain fragility, and rapidly changing threat profiles. Designers had to learn on the job, testing ideas that had never before been tried within their own aerospace tradition. Despite these challenges, progress was relentless. Every flaw became a lesson. Each setback, a push forward. From flight control software to radar integration, the program embraced iteration. This willingness to revise, rework, and refine is what turned the J-20 from an experiment into a cornerstone. In many ways, the jet now shapes expectations for what comes next. It has laid the foundation for unmanned combat aircraft, next-generation stealth bombers, and space-aware defense strategies. Its legacy will stretch beyond its own airframe, setting standards and sparking rival projects across the globe. Foreign militaries, once dismissive of its early form, now treat it with caution and respect. Red teams simulate it in wargames. Tactical manuals reference its capabilities. Defense budgets elsewhere are reshaped to address its potential. The aircraft has become more than just metal and code, it has become a challenge, a benchmark, a moving target that continues to evolve. The story of the Chengdu J-20 is not just about a single aircraft, it is about transformation. It marks a turning point where aspiration meets realization. What once seemed unreachable, a domestically developed stealth fighter capable of challenging the most advanced systems in the world, has now become a soaring reality. In the skies, the J-20 commands attention. On the ground, it inspires development. Across seas and borders, it shifts conversations and forces recalibration. This aircraft has become a statement about progress, independence, and confidence. Its silhouette may evoke comparisons with other stealth platforms, but its identity is unique. The J-20 does not simply replicate, it innovates within its own context, shaped by different needs and strategic perspectives. Where others might rely on traditional design paths, this jet reflects a different vision, rooted in long-term planning and systemic integration. Looking ahead, the J-20 will likely serve as a launching point for further innovation. New materials, unmanned wingmen, quantum navigation, and adaptive camouflage are no longer dreams, they are emerging realities that will build upon the groundwork laid by this aircraft. Its influence will continue through upgraded variants, new mission profiles, and experimental doctrines. The evolution of the J-20 is also a mirror to the evolution of national aerospace capability. From early flight models to a fully operational fleet, it represents a climb not only in hardware but in confidence, self-reliance, and influence. This journey echoes the rise of an aerospace culture, one that values discipline, daring, and vision. Even as new generations of aircraft emerge, the J-20 will remain relevant. Through upgrades, role expansion, and digital evolution, it will adapt to new eras of warfare. Already, discussions surrounding loyal wingman drones, high-altitude stealth surveillance, and even space-integrated combat frameworks are influenced by its design philosophy. For the pilots who fly it, the J-20 is more than machinery, it is a trusted partner. For the teams that maintain it, a source of pride. For the strategists who deploy it, a vital asset. And for the observers who watch it, a symbol of shifting tides. The sky has always been a theater of ambition. With each roar of its engines and each silent approach over contested ground, the J-20 carves its place into that theater, not as a copy, not as a shadow, but as a presence. A presence that speaks of change, progress, and a future that is being shaped wing by wing. Thus, the Chengdu J-20 stands not only as an aircraft, but as a vision lifted by wind and wool, unseen by radar, yet impossible to ignore.